Hi, this is the 3D printing lawyer. In today's video, I'm going to be designing a container for some Uno cards. Someone in my household, I haven't really dug into who, threw away the box for the Uno cards and had wrapped the cards with a rubber band. In this household, that just isn't going to do. We need to engineer that. Replace it with a 3D printed part. So that's what we're doing today. And, as it so happens, that our Uno cards are the Minecraft version. So I was thinking of doing a themed design. So here we are on copyright.gov. I was going to see what Mojang had registered copyrights on. Now, they don't have to register a copyright for a work to be copyrighted and to be protected. They do have to register if they want to sue. So let's see kind of an idea of what Mojang cares about. So I'm on copyright.gov here, and this disclaimer is whack. You can either acknowledge or just close. So let's go with the closing, I guess. I'm going to type Mojang, which you can see I've already done. So I'm using the copyright's new public record system. I'm going to scroll down and just filter on visual material. I thought I would have to click apply, apparently not. Are they requesting feedback? Because I want to give them feedback. Because it's not sorted by any. I don't know what it's sorted by. It doesn't seem to be sorted by anything. I want it by title. By default. Like, why would you just have no sort by default? Let's do 100 rows. Okay, so I'm looking specifically for pig, because everyone likes the Minecraft pig. They have registered for copyright, pig, the pig face, and the pig side. I'm seeing sides and fronts, which probably means they're basically trying to copyright the 3D designs. That's fair, I guess. I did notice when I was on here earlier that they didn't register the creeper. Like, why is the creeper not registered? Isn't he like the most iconic Minecraft character? Anyway, I'm not recommending that you do the pig. I'm not gonna do the pig. However, there are only so many different ways that you could do a blocky pig. The idea of a blocky pixelated pig can't be copyrighted because it's an idea. There are only so many ways you could do it. A block for the head, a block for the body, blocks for the arms and legs. It's going to look kind of like the Minecraft pig, whether you're trying to make the Minecraft pig or not. But there's also something else, the chest. The chest isn't on here, and the chest makes sense for putting cards inside of, right? Because it's supposed to have things inside of it. And if I was going to have the pig, would I put the cards in the pig's head or in his back or maybe in its butt? So this is what we're going to do. We're going to do the chest. And specifically, we'll probably do the double chest because the chest is a cube and the cards are rectangular, not square. So let's go to the other thing I'm going to do is I am going to have the banding on the corners. So I'm going to try and design that into the chest. But that's quite common in all chests, not just Minecraft chests. So let's get started. I'm actually going to get started with parameters, and I think that's under Modify. So one thing I recommend is that we go ahead and add parameters to our strip menu. So I'm going to click on this 3 dots and pin to toolbar, and that puts it up there. Let's go ahead and create some user parameters. So we haven't really had to do this in any of our other designs. I think I might have mentioned it, but probably not. Like, I don't think we've had anything that has had to couple with something else or had to interface with anything. With my Bambu Lab A1 printer, what I find is that if I want, for example, a round peg to go into a round hole, the peg and the hole can't be the exact same size. Of course, my square pegs also won't go into the round holes. The peg for a tight fit needs to be 0.2 millimeters smaller on the top and bottom. And then that would be basically 0.2 subtracted from the radius. And then for loose fit, I would do 0.3. So let's go ahead and add those, and we'll add them as user parameters. So I'm clicking on user parameter, click up plus. I'm just name this tight. Then it's going to be 0.2. Name this millimeters. I'm going to add loose as 0.3 millimeters. And then the other thing I'm going to do is I'm basically going to make the outside of the chest 4 millimeters, specifically because when the chest is open, I want to have the hole, but then I want 2 millimeters of wood, and then this would be 2 millimeters of the what did I call it before? The banding, metal banding. And then we actually know that the dimensions of the cards. So the cards are 56 millimeters wide. Oops. And we'll just name this W. I'll put width on cards. And then we'll do height of cards. I found that to be 87.1. And then when stacking the cards on top of each other, just under the weight of their own gravity, I am measuring the thickness of the deck, and I might call that T. The dimension was 34. Right, one click on OK. Right, so let's go ahead and start drawing the chest. I'm going to do create sketch. And you know me, I like to do it on the XZ plane. What do they call it here? Do they call that the bottom? They do call it the bottom. So XZ is the bottom plane. So I'm going to create a center rectangle. And a lot of times I start at the origin, just because it's easy. But I'm going to save some time, as I'm going to want the origin planes. I'm going to hold down shift to middle mouse button drag so you can see. I'm going to use these later for mirroring parts. So I'm going to actually draw centered rectangle. So I'm going to click here. And then I'm just going to do, tell U by H. And then press enter. And then I don't see a reason why we shouldn't just go ahead and extrude this up. And we would do that. T. All right, so there's our deck of cards. Should fit in that, right? Except when we do the exact same size. So we'll go back in here. We got to add W plus, and then we want it to be loose, I think. So we type loose. And because we need it to be loose on two different axes, we're going to do loose times 2. So we need it this side and on this side. And then I'm going to do the same here. All right. Let's finish sketch. All right, so there's our deck of cards with the allowance added for the cards that actually fit in. What I'm going to do now is I'm going to use the shell tool. We'll make this a shell because this is the size of our deck. In order to make this a crate that holds the deck, we actually want to thicken the outside to fit the deck. So let's change direction to outside. And the thickness is, remember we did our 4 millimeter, what do we call that? We call it thick. Yep. All right, so the cards will just drop in there. That should be good. So the next thing I'm going to do is create a leather sketch on this side. Because in general, the chest is made out of 2 cubes. So I want to make it a square on this side. So let's create another sketch. I'll actually create it on the space here. And in my previous videos, I told you to ask for search and then look for the project tool. By default, also, and press the escape to make that disappear. The project should just be the P key. Click inside in the profile that I want to project to my sketch. And I just want to draw a square here. Grab the rectangle, 2-point rectangle tool. Well, we just go over here and see how wide this is. It's 64.6. So then we'll go tab and we go 64.6. And there's our square. And then I want to extrude this. I'm doing shift middle mouse button drag again. This will be the lid. So the cards will completely fit in the bottom. The lid's mostly just for decoration. But, you know, we do need a lid. Extruding. Or again, I'm going to hold shift middle mouse button drag. And when extruding, by default, if you just click on this face and it's already set up to extrude the distance out of that face if you click on it. That's perfect, except we want it to be in the body. Press OK. We could probably name more bodies. So body 1 is the bottom, body 2 is the top. So if we hide the bottom, and see the top's still solid right now, so we need to hollow it out. So when it do that again, we'll select this side. I want to shell it. And this time, because it's already the size we need, and we want to make it the hole on the inside, we won't change the direction of the inside. We won't change this to thick. There's the top. See the top, bottom together. Let's go ahead and inspect with a section analysis for cut plane ornament. Use the origin XY and press OK. So we can see the inside. And that when we're done with this, we're going to need it for the whole project. You can go hide it. Alright, so now we can start doing our designs. So basically, we already have a sketch on this face, but doesn't include the shape, or does it? It does include this shape. So let's go ahead and just do that. All right, it does include the shape, but doesn't include the extrusion. So let's create a new sketch. I'm going to clear it on this face. I'm going to type P for project. And we'll select this profile, hit OK. So basically, all we want to do here is bring in the 2mm edge for the banding. So if you remember, that's basically what the modified tool does. We'll drop it down and be -2, or should we do thick broad legend? Oops, except it's minus. I'm going to do the same thing here. Right, so then to make this, I'm obviously going to paint this. I mean, we might do a second version where we do a 2-color and doing 2-color in multi-parts where we snap the pieces together. Well, one reason I really like that when I do it that way, and why I say you don't really need a multicolor printer, is because if we were to make these wood and these dark brown, like we could print this side so that this side is on the build plate, which makes it completely smooth. If you have a smooth build plate and this side, and then we just snap them in, and then all the sides are smooth and you don't have layer lines. So if you want multicolor, in my opinion, you should just make up multiple parts. So anyway, we are going to bring these signs in. So I'm selecting them, as I have a select tool. I'm going to do solid extrude, and we actually want to cut. And we want to cut probably 0.2 millimeters. Same, no objects to cut. When our body is invisible, Oh, because we did positive or negative. Right. I think it's 0.2. All right, so then if we were to paint this, it would be really easy to paint the black and leave this unpainted. So, I mean, we could even fill these with a party to get a different color if we wanted. And so then I'm going to mirror this, the extrusion. So I'm actually going to select the extrusion and then create a mirror. And I want to mirror on this point right here, which is hard to select. Let's hide the bottom. Oh, it's not unselected, that's why. So we deselect, but it's easier. Yep, right. So when it's ready to select the mirror plane and not the features we're trying to mirror, then you can just mouse over these and the one that, the white up. So you want the XY plane, press simply. So seeing what we're doing here, we're going to be done pretty fast if we keep doing it like this. So the top and the bottom aren't equidistant from each other. So we're going to have to create a construction plane for that. Right now we're going to do this other side. And I'm holding the member mouse button and dragging to center this. I'm typing P for project. I'm going to select both profiles and hit OK. I'm going to offset both of them again. Because it's minus thick divided by 2. And then I'm going to select both of the profiles, wanting to extrude them, and we're extruding minus 0.2. They'll automatically switch to cut because we're going in that direction. We'll do OK. And then we'll select our extrude and mirror, because we're actually mirroring the features. And then we will select rear plane, and this time we want this plane. Why did that work? We'll show the solid errors. Fitness features. Oh, I had the wrong plane selected. Oh, come on. X. Y is G. And then, okay. So then we need to count the bottom. So one thing we're going to do to create the plane we need that's equidistant between the two is we do construct, and there's one called min plane. You can just select the top face and the bottom face and press OK. And it's called construction plane. I'm just going to call this menu. And then we're going to create a sketch on the top. How they know? So P for project. Right on the light plane. No. So we couldn't change the plane on its own. And select the top, which is what we want to do. And then draw or offset. And choose minus. So develop my tin. Select, and we're going to select the top. Solid extrude. And we're going mega 0.2. And I would like to mirror it less. To the middle. What did I do? Why? Maybe it's because it's a different body. I'll try one more time and then we'll just create another sketch. No pattern instances could be intersected with the original body. You know, I guess it's because it's a different body. That makes sense, I guess. I'm just creating the sketch on the bottom. P for project. Since our rectangle, we'll offset. Minus thick. Divide by 2. Select profile. I'll push it in. Doing a cut. Alright, so that's our basic chest. The only thing left to do is the wedge. So let's do a wedge. So looks like the wedge is on the top. Yeah, that makes sense. And probably starts about in the middle. So how are we going to do this? Because we're trying to print with no supports. So this is actually going to be an overhang. When we print the bottom part is this edge right here. And this body, the top, we're going to end up rotating. So let's go ahead and rotate the body. And for the axis, we will select this edge. We'll do 180 degrees. And why does it do free move and drag it over here? So if we draw the rectangle, or the, yeah, it's rectangular cube, right? Rectangular object in 3D here, we're going to need a support on the one edge. So we will deal with that in a minute. Said Stephen, create. Wonder if we should create the sketch, or use the other sketch how we already have. So we gear all the sketch on that plane. This one. Hmm. So let's draw I want a center point. Right angle maybe. And start with that. So this is, so do you drag your mouse, it's gonna kind of snaps here to the halfway point. Kind of whatever you want it. So let's see how it looks right. And this was about halfway. If you drag the mouse over here and snap to the halfway point, and then draw left, it'll give us this guide that we kind of need. So that's 8.07 millimeters. And let's just go ahead and make it 8 millimeters. This, we don't want it to go, and it doesn't need to go the same distance. Could I mean to lose our spot? Let's just go ahead and make it 26,600, and then we'll move to the other side. Except I don't know if it's gonna let us. It's been just right click there and remove. Oh, yeah, because it's a center rectangle, it keeps as a center rectangle. So what? Get rid of some of these, what do they call it? Constraints. All right, so this is a 10 constraint, is that? Horizontal constraint. We do want to execute that one. This is a parallel constraint. We do want it to parallel. And this is probably 9 degrees, which we do want. What's this? A midpoint constraint. I bet that's one we don't want. And this is an offset constraint. But we don't want those either. Don't need those. All right, and then we should be able to move this. Right about there. Ish. Right, and then we'll get and select all of hymns. I ready to select all of them and the solid extrude. Let's make sure that the top is visible. That way it joins to the cap. And we'll extrude it a bit. We kind of want to be a rectangle on top, right? So we should be 8. Was that 8? That about looks. I don't think you not that far though. This is 2/6. Even that looks excessive. Let's just do 4, which is our thick. What's too thick? Okay. So let's see what we're looking like then. How do I manage to drain it to the bottom? Hey, I see what's going on. I mean, you're doing this. So before we moved the top, and then I could join it to the top instead of the bottom. So you just learned how to move operators in order that you need them to be. It's kind of an advanced topic, but this is almost what we want. So right now, the only thing holding them together is gravity. But also we have this section right here that's going to need support. So I think we'll do that first. Just chamfer it. And chamfer it for 4 millimeters. Which was, I guess we could type thick. Not thick. Is it thick? Yeah. Okay, so now I can paint one out supports like that. So I'm gonna look way under. Should we do it to the side too? Yeah, I think that looks better. Okay, so as I was saying, the schema stay shut with, just gravity. So I think the first thing you want to do is you want to make this lip go higher on the inside so that when the 2 parts are resting on top of each other, that there's not a crack there that a card can slip through. You'll see what I mean in a second. So we'll create a sketch on this face right here. Do you project? Well, this one and this one will press OK. And then I think, so this is the banding. Right, so the banding is, we made this 4 millimeters, so the banding is 2 millimeters here, and then, or 2 millimeters here, and then this is the white part. So we'll use it to do an offset right here. Do 2 millimeters. Or thick, smell the tube. Okay, on this profile, I'm going to raise. Let's do, let's see what 2 looks like. I think I want more of the lip than that, and it's just too far. And then we're to lower this the same amount. So let's create sketch. And project. All right, so we need to go out offset from here. We need to offset. Great. Now that's negative. How come they're both negative? Oh, let's do that. All right. So we don't want thickness divided by Q. I don't want thick divided by Q. And then this is positive, right? So, and then we want to add the allowance, and we want this to be loose. Then we need to cut this. We need to make it, for me at 4 millimeters, we want thick plus, and I want this one to be tight, and it's only 1 dimension, so we don't need to do the tight times 2, we just need tight. Oops, that was supposed to be cut. So negative. All right, so this should go into here. I think we're good. At version 2, or in the next video, we will figure out how we're going to link these. Would it be a linkage? I don't know. Well, we'll figure out what type of mechanical fastener we want to keep it close, because I don't just want gravity. Got questions? Drop them in the comments below. Please like this video. Thank you for subscribing. Have a good day.